let's start with our first speaker, Professor Georgios Yannakakis, who is the director of the Institute of Digital Games and the coordinator of the project, who will be presenting LearnML and its outcomes. Georgios.
Thank you so much, Hiro. Thank you, everyone. Welcome, everyone. This is, as we call them, the AI in School Education webinars, online Facebook Live webinars. Hiro is your host. I am coordinating what is called LearnML. It's short for Learn to Machine Learn project. And what I will be doing today is taking you through the basics of what this project is about. Introduce basically the I'll start by introducing our. Sorry, let me see what comes next. It's here. It's basically what this event is about. We have a wonderful panel of speakers. We have Henrik, Køhler, Simonsen representing DS4AIR project. We have Panagiotis Petridis representing the AI Adventures project. This is like a collection of 3 Erasmus Plus projects at the intersection of AI and education and games or media, right? Which is quite fascinating. It's like a lot of interest in ways we can use technology, games to teach younger generations the principles of AI. Then we have more invited speakers. We have Irene-Angelica. She's going to take us through basic principles of machine learning and student modeling in her work. Then followed by Vanessa Camilleri, colleague of ours here at the University of Malta, the Faculty of ICT, will take us through the basics of AI and basic concepts of AI and machine learning for educators. Then we have Desiree Bugeja and Josmar Borg. These 2 people are working with the Ministry of Education here in Malta and will take us through some of the early findings of evaluation of the LearnML project, or whatever we developed in terms of games and educational material. And then we'll end this event today with Elena Georgiou and Theodora Tsiabasi, both teachers, educators that have tried out our games, tried out our educational material, and they want to share their experience with us, which is great. So it's quite holistic what we are offering here today, quite diverse. So let's get to it. Basically, I'll start by giving a couple of slides about the organizing entity here, the Institute of Digital Games, and then I will take you through the basics of LearnML. So basically, the Institute of Digital Games that coordinates this project in collaboration with the Faculty of ICT at the University of Malta. It's about 20 plus academics and researchers approaching games from various perspectives, from engineering to AI and social sciences to art, design, and so on. We're highly multidisciplinary, highly multicultural, and I've been quite active in the area of game design as can be assisted by artificial intelligence and as it can be assisted by game studies and game research in general. Quite active in publishing sort of books about those intersections, but and also quite active when it comes to funding programs within the European Commission and local ones, especially within the areas of game-based learning and the use of AI and games for various different applications, from media to computational creativity to effective computing and so on. Now, one of these projects is the LearnML, short for Learn to Machine Learn, which is what we're here for today. As Hiro said, this is a 3-year Erasmus Plus project. It's 2.5 years on the way. We're almost done. We're over in August. We have achieved a lot, as you will see today, and we're in the final phase of evaluating what we have, basically what we've managed to build with regards to evaluation material, educational material and games. Now, it is a multi partnership, let's say, project. It involves 3 different countries, from Greece, Malta, and Norway. We have the Norwegian University of Science and Technology, the National Technical University of Athens, Palladio, schools in Athens, and then Science Centre Pembroke, Malta, which is a department within the Ministry of Education in Malta. So now, what is the vision of Learn to Machine Learn, or where the idea comes from? The idea came from like 3 years back when we're all witnessing the so-called fourth industrial revolution and AI being a core part of it, and at the same time witnessing the massive widespreading of games throughout our population, and especially young generations. And we could see an opportunity that we could use games as a medium to train younger generations about the basic core principles of artificial intelligence. Why would we want to do that? Because if younger generations get trained properly on what AI is, the benefits of AI, the problems of AI, and the risks that are associated with AI, and excuse the background noise, if we could do that, then we could create better citizens, or more responsible citizens of Europe on the one end, and on the other end, we could possibly have better algorithms out there governing our daily lives. Because AI, as we all know, is more or less everywhere nowadays, within our mobiles, all the way to our cars, to anything more or less that we do within human-computer interaction or human-machine interaction. So yeah, we thought, how about using games, bring them as a teaching medium, and bring artificial intelligence education into primary school, like a form of AI literacy, enable what is called AI literacy these days. So more formally, the vision of the Learn to Machine Learn project is to produce solutions for teaching and learning crucial 21st century skills, as those are related to digital literacy, computational thinking, and AI. So that, as I said earlier, we can develop more responsible citizens, European citizens, and insightful thinkers that are able to navigate complex digital spaces and effectively contribute to the design of new algorithms, better algorithms that they're there for good, for our own good. So how would we do that? Well, one idea was to essentially transfer what is called the notion of AI literacy to primary and secondary education, and a core aim is to introduce students to the principles of AI and machine learning through games, or what we called it, a game-based educational toolbox. So these are some early attempts of ours to actually do that. Very early days of the project, like first few months, we had an ongoing collaboration with Microsoft Research, and we thought, okay, we want to teach AI through games. The best game out there is Minecraft, right? So let's try to do that. So this is really, really early days, where we created some prototypes. We went back to the teachers, sort of co-designed or discussed about ideas that we had, digital prototypes on Minecraft. And back in the days, we're training an agent to go from A to B. Like, you have this avatar that needs to go from A to B, and the student would play with the brain size of the artificial intelligence and the time that it has to actually reach the goal, and so on. While intuitive and cool because it's Minecraft, we soon realized that we're quite limited by the let's say the accessibility that we had on the game engine. So we had to abandon the Minecraft sort of path quite early. So instead, what we did next was to look at Unity engine, game engine, and several packages that exist there for artificial intelligence and machine learning, like the Unity ML framework, and started designing Unity-based games, co-designing Unity-based games for educators. So several sort of paper and digital prototypes after. A few months ago, we introduced what is called the Artbot game that I will be presenting today, and its associated portal, let's call it like that, it's going to be announced today. And how did we do that? Well, in addition to the game, we had an associated guidebook, and that was co-designed with educators. So we designed and developed educational scenarios and material, not only for the classroom, but also material that is able to support remote teaching and informal learning, at home, for instance. And whatever we designed and constructed was based on along two axes. On one end, a theoretical background about artificial intelligence and machine learning, and on the other end, game-based learning scenarios that could be used in classroom, informal or in informal settings. So here's some numbers, some statistics. What have we managed to achieve so far? We've managed to educate more than 150 teachers. We're quite proud about that. And more than 50 teachers and 110 students managed to review and co-design parts of the games in the educational material. So it's quite inclusive focus group approach here to deliver what we deliver back to the classroom. So from educators to educators, in a sense. This and here are some numbers about the impact that we have achieved as a whole, as a group as a project, group of people working with games that they teach artificial intelligence. The game Artbot, I will be presenting soon, has managed to get about 250 monthly players, which is quite impressive for a game of this type. And it's still early days. I mean, one of the reasons we are disseminating, we are actually holding this event is to further disseminate the use and the coolness of the Artbot game. We have quite an active Facebook page and social media pages, and through these online webinars, we managed to reach more than 3,000 people. During the COVID era, obviously, being online was quite popular. And also, we managed to appear on several sort of media disseminating about what we are doing here in LearnML. So, right, so let's look at the Artbot game, which is available at Google Play. This is, again, a co-design process between researchers here at the University of Malta, educators, and other partners in the consortium, and students, actually. So it's a collective effort. And basically, what we had in mind as an idea was to have a bot, some sort of like entity, an avatar that is trained through the basic principles of supervised learning and reinforcement learning. So we had like two phases in the game, but those two different phases are connected through some sort of like aesthetic coherence and sort of story coherence. So, so the child comes in, selects a bot, an avatar, and then the child provides data. In this first scenario, paintings versus sculptures, right? And then it basically tells the bot that, this is a painting versus this is a sculpture and so on. And then on the right side of the screen here, the child is selecting particular parameters of a decision tree, like, what are the things that decision tree should look at, what, how deep the decision tree should be, playing a bit with the parameters, and then observing the effects of this training process. So directly being involved in training a supervised learning algorithm, right? And once that phase is over and your bot has now learned how to predict sculptures versus paintings, then it should be able to go into a virtual museum and be able to identify the sculptures that they are and collect them, right? So that's the idea. The second scenario is about teaching the basic principles of reinforcement learning, which is basically the process of learning from good rewards versus bad penalties, right? So the child themselves, the children themselves can identify what is good. Good is a sculpture, bad is those sort of pins, right? You should avoid those. And then good is also to get away from this virtual museum. And then again, by playing through basic reinforcement learning algorithms, parameters of reinforcement learning algorithms, the child is exposed to reinforcement learning training, right, of an actual algorithm, and how particular selection of parameters can affect learning and can affect the outcomes of artificial intelligence. So today, that game is available at Google Play and is available at our website, learnml.eu. But we thought that it would make much larger impact if all the educational material associated with the game and the game itself is available in a common place. And today I'm happy to announce this wonderful sort of website that we created. It's called artboard.net. So you're welcome to visit that, where you can actually play the game online, download it to your mobile or sort of, to your mobile. And also download the educational material that is associated with this game. Go through our publication list. It's basically all the website hosts all necessary information that you need to have for directly using this game in classroom or for any informal settings, educational settings with regards to artificial intelligence, teaching artificial intelligence in primary and secondary schools. So yeah, feel free to visit the website artboard.net. Let us know what you think. We're here to go through your constructive feedback. And beyond that, if you're interested in what we're doing here, feel free to follow us over Twitter, Facebook, and check out our YouTube videos. So once again, thank you all for being here. Thanks to the people that accepted our invitation to join this webinar and give us their views on anything that relates to AI literacy through game-based learning. And thank you, Ro, for hosting this event.
Thank you very much, Georgios. If you have any questions or comments, please post them on the chat channel, and I will be posting the links for the site and for the game as well later on the chat channel as well. Our next speaker is Henrik Simonsen. He's an external lecturer at the Department of Management, Society and Communication at Copenhagen Business School, and Director of Resources and Projects at SmartLearning. His areas of expertise and interest are business consultancy and information management, online learning and AI, digital business models, business development, information management, online learning and AI. And he will be presenting the DS4AR project, as Georgios mentioned earlier. He will be describing, the aim of the project is AI related skills for employers and employees. And he will be presenting the modules and AI-based elements developed in the framework of the projects, if I'm correct.
Yes.
So, Henrik, thank you very much. Welcome. Thank you very much for being here.
Thank you. And I trust that you can see my screen, right?
Yes, excellent.
Right, okay. Thank you very much, Igor, for your presentation. And I'm honored to be able to present some of the initial findings and results from the DS4AR project. And as will appear from the slide here, it's about fostering or facilitating the digital skills for the artificial intelligence revolution. And it is indeed an Erasmus Plus funded project, and the reference number has been stated here on the screen. Georgios, you talked about early days. This is really early days. So I'll only be able to present our initial considerations and framework. And that's my approach to this presentation. Right, let's take a look at the next slide. This is a screenshot from our website, and it's about digital skills for the AI revolution. And as you also presented, Georgios, you can actually access the DS4AR website and get some additional information on the project. Some of the objectives of the DS4AR projects are listed here, and I will primarily be focusing on the training part which you can see in the right-hand corner. And the training part is about developing AI-specific or AI-based training to two different target groups, employers and employees in all over Europe. And we have been working hard to identify the needs of the employers and the employees. And I'm going to briefly show you our surveys. Now, some of the theoretical basis of my presentation, I've decided to leave it out, but obviously we have based our framework on an empirical, or not empirical, but a literature review of relevant literature on AI and in this case, chatbots. And what I'm going to show you is later is how we combined the theoretical considerations on how to use chatbots. And we are drawing extensively on Volny et al. 2021, Smotny and Sherepova 2020, Thomas et al. 2021, Fryer et al. 2020, and Hughes 2022, who wrote a very interesting article about the empathetic elements of chatbots. In addition to that, we have also used theoretical considerations on dialogue design, because we argue that when you implement AI-based chatbots, it's not about technology, it's actually about the dialogue design going on between the human user and the AI, and I'm going to show you that in a minute. And we have used McCarthy and Wright 2007 in their seminal book on dialogue design, and Helm et al. 2007. So that was the boring introduction, but it's really, really interesting to see that there has been so much interesting theoretical work being done already on this area, or in this area. So I'm going to focus on, as I said, on the right-hand corner, the training part, okay? So again, a credit to all the partners. B&P Emerging Technology is the lead partner of the project, and we are represented from Spain, Malta, United Kingdom, and Denmark. And I've been asked to do this presentation today on behalf of the entire group. So, what did we do to meet the first defined deliverable? We started out by doing a very, very detailed literature review of artificial intelligence and needs and chatbots. And then we designed and implemented an employer survey and an employee survey. So we asked the two target groups of our modules. We are still processing some of the data from these surveys, but it was relatively clear that there is a huge need for AI knowledge, and not only knowledge about AI, but how to use AI in the workplace. So working on that assumption, we started designing the 8 modules. And the lead designer is actually present in the among the participants today. And thank you, MEDE, for showing up. And she's heading the entire design of the 8 modules that we are developing. So the training modules that we are developing, 9 modules, I apologize, are listed here, and you can take a look at the nine names of the different training modules. What we want to do with these 9 modules is to cover the entire spectrum of how to use AI in the workplace. And as you can see, different partners have been assigned different tasks. I'm going to show you briefly the introduction to AI course in a minute. Right, so this is actually the platform that the lead designer has used. It's a standard Moodle platform, and I will just switch screens and show you what is going on. If we do like this, I'll just do like this, and again share my screen. I apologize for the yeah. So this is the actual learning management system, and it's placed in our own virtual learning environment on platform SmartLearning. So just a brief flyover of this particular module. It's been designed to work towards the work-based training, right? So it's brief and it's short and it's concise, and it's designed to be used in a workplace. So again, introduction, what is artificial intelligence? So we've decided to use a number of illustrative videos like this to illustrate what is going on, because in the workplace, we don't have time to read a lot of text. So this is what we'll be able to do with all the 9 modules at some point. So this was the first deliverable out of the 9 deliverables. But we decided to do more. We decided to actually offer the users access to an intelligent AI-based chatbot. So what we've done is actually implemented the Watson AI chatbot in all our modules, and I trust that you can see the blue screen with the thank you, just to make sure, right? Right, okay, before I do that, I would like just briefly to state that obviously we define 2 specific purposes. The first one for the chatbot, that is, the first one was to give people a cognitive assistance, that is, help people acquiring new knowledge, and on the other hand, to give them access to operational technical assistance, right? So if you are working in a workplace, that's what you probably need, or at least that was what our survey showed. So again, we developed some sort of model, which we called Learn, Do, Ask, Find. So every time the learner or the worker at the workplace needs information to acquire knowledge or needs operational help to set up technical stuff, he will consult the AI chatbot. And it's based on an additional framework like this, where you have not only students and chatbots, because this is also available in digital learning environments, and that is described and discussed in Simonsen 2021. But what we did was we actually implemented that in a work environment, which means that the worker or the employee can talk to not only the chatbot, but also his peer, his colleague, and his boss. So that was the theoretical framework of what we did. And it soon became clear that what we're talking about is actually some kind of mediator role here. On the left-hand side, we've got the employee, and on the right-hand side, we've got the AI, right? But in the middle, we have the chatbot. And to realize the full potential of AI, we decided that we wanted to use really elaborate dialogue design between the user and the chatbot. So again, this model shows how the user consults the chatbot consults the AI, and the AI goes through a number of iterations, finds a question or an answer that the user might be able to understand and might be able to use, and it returns it to the chatbot, and the chatbot returns that to the user. So that's what we might call the cognitive data journey between a human user and the AI user. Right. So let's take a look at the chatbot itself. It's placed on an IBM Watson platform with AI search skills implemented. And as you can see from the screen, it's really simple. Again, bearing in mind the workplace environment, you can ask for content-related help, or you can ask for technical help. And if you do that, or you can ask, if you want to listen to music, you can also do that. Actually, it's findings from Hughes, which underline the fact that the more empathetic and the stronger the chatbot personality, the higher the technology acceptance it is. So with reference to the TAM model, the technology acceptance model, we've decided to do that. So let's take a look at the chatbot, because it is actually alive. And what we've done is we've just started developing the modules. And so I can only show you just a brief lookup. So I want content-related help, and it scurries through, and I want to, it offers me options here, and I go for AI bias, for example, and it offers me fixed data that we have decided to use or to program inside the chatbot. But we could also go on asking search skills to find additional entries about AI bias. Again, it's a question of, it's a balance. Do we need more information or less information? Because actually, in the end, it's designed for this particular device. So allow me to wrap up. I think my time's up. So we've decided to support the learning needs of employers and employees about artificial intelligence. And we support that not only by creating 9 modules, but also offering them a personal learning assistant called DS4AR bot. So thank you very much for your attention. And I would love to discuss that in a minute. Thank you.
Perfect. Thank you very much, Henrik. Thank you. Very fascinating. If you have any questions, please post them on the chat. After the next presentations, we'll have a few minutes for discussion or questions you may have. I don't know if our next speaker is here, Panagiotis Petridis. I'm not sure if I can see him in the participant list. I guess he's not here. He hasn't managed to join. So maybe we can go to our next presentation next speaker by Irene-Angelica Chounta. I think she's here.
Yes, I'm here. I just needed to find the unmute button. Hi.
Perfect.
Hi, everyone.
Hello. Hello, Irene. Great to see you again.
Great to see you too, Iro.
Irene is junior professor at the University of Duisburg-Essen, Department of Computer Science. Sorry about that, it was the timer. Department of Computer Science and Applied Cognitive Science. Her research focuses on computational learning analytics for technology-enhanced learning. And in her presentation, she will be talking to us about her work, her research on student modeling and how to bridge the gap between pedagogical theories and data-driven practice, and about the zone of proximal development, I think, Irene.
That's exactly it. Thank you, Iro. So, yeah, hi, everyone. I'm really super glad to be here today. So thank you for the invitation. And thank you also for attending this talk. Today, as Iro already said very nicely, I will be talking about designing, developing, and deploying machine learning approaches with the aim to model students' cognitive and knowledge state, and consequently to support learning from the perspective of personalization and adaptation. So before proceeding, I will use this opportunity to introduce myself and my career path so far. I was born and raised in Athens. I studied in the University of Patras electrical and computer engineering, and I did my PhD there on human-computer interaction in educational technologies, where I also met Iro. Then I moved in 2014 in the University of Duisburg-Essen as a postdoctoral researcher back there. I used with Professor Ulrich Hoppe on learning analytics. And in 2016, I moved again as a postdoctoral researcher in Carnegie Mellon University, where I worked with Bruce McLaren on intelligent tutoring systems. I followed up, I moved to the University of Tartu in Estonia as an assistant professor of learning analytics. And now in April 2021, I came back to Duisburg-Essen as a junior professor of computational methods in modeling and analysis of learning processes, where we also have a very nice lab working with machine learning and artificial intelligence in education. Okay, so the main challenge that I aim to address with my research is to support learning by modeling learners' cognitive and social and affective state by using artificial intelligence, namely mainly machine learning, to analyze data traces and consequently to provide personalized and adaptive feedback that addresses students' individual needs. So in this sense, my research focused on using artificial intelligence in order to develop computational models of human cognition that will allow us to design these personalized and immersive learning experiences. So more importantly, I'm aiming to grounding these data-driven feedback approaches using pedagogical reasoning and establishing social cognitive theories contributing to new learning paradigms. And having said that, today I will be discussing how we can use students' data to personalize instruction and content in the context of intelligent tutoring systems with the use of machine learning. So to that end, and actually my talk, I think it fits very well to Henrik's talks. I was very happy to hear that. Thank you, Henrik, for the wonderful discussion. So I will present here the case of REMAC. REMAC is a dialogue-based intelligent tutoring system that aims to support K-12 students who learn physics by engaging them into adaptive tutorial dialogues. This was a project that we had in collaboration when I was in Carnegie Mellon, that we had in collaboration with the University of Pittsburgh, LRDC. I will just mention the names because I have to give the credit where it's due. So Patricia Albacete, Pamela Anderson, and Sandra Katz, and then Bruce McLaren and me in Carnegie Mellon University. So I think you all know, but I will repeat it just to make sure that we have a common understanding. An intelligent tutoring system is practically a computer system that aims to provide immediate and customized instruction or feedback to learners, usually without requiring intervention from a human teacher, right? So to engage students in tutorial dialogues, what REMAC does is that we use dialogue scripts that are known as directed lines of reasoning. And I like that I see Henrik saying yes, nodding. And we use this dialogue script to generate dialogues on predefined reflection questions. So what this practically means is that the tutoring system works with a set of reflection questions that the student has to answer as they practice on a specific topic. And each of these questions is accompanied with additional sub-questions of various difficulty levels. And these sub-questions represent little pieces of knowledge that the student must acquire in order to answer the main reflection question that the tutor has posed. Having said that, the question that comes up from modeling perspective is how we can adapt the student path. So how the student moves within the directed lines of reasoning, and to do that in real time. So practically, how do we decide what question to ask next, and in an optimal way in terms of learning games, right? Okay. So to answer these questions, we build on the work of Lev Vygotsky on the psychological development of children, and specifically we use the zone of proximal development. And one could argue here that this is what teachers do when they teach their students, right? So teachers regulate their tutorial dialogues with the goal to adapt the level of discussion to the student's zone of proximal development. And I'm sure that you know, but let me just briefly remind you that when we talk about the zone of proximal development, we mean this cognitive area where the student can carry out the task successfully if they receive appropriate support from a knowledgeable other. And this knowledgeable other can be the teacher, can be a parent, can be a peer. In this case, we talk about the teacher. So human teachers have a way to do this adaptation of their tutorial dialogue and instruction in a kind of instinctive, let's say, way that they learn, of course, through their studies and also through experience. So the teachers, they have to assess in real time the cognitive and knowledge state of their students using, for example, as input students' responses to their questions, even students' facial expressions when engaging with a learning task. And our idea here was, what if instead of the teacher, we could use a student model, so a computational data-driven machine learning model, to assess the student's knowledge and cognitive state and identify whether the student could be in their zone of proximal development, above it or below it, right? So again, the question here is, can we practically play the teacher with our student model? So to do so, we used as input data about the student's background knowledge, the task difficulty, the prior practice students may have had, and the help that they might have received. And all this information is tracked and recorded by the tutoring system. And what we did is we trained a student model and a machine learning model. And in this case, it was an item response logistic regression model. And we trained it as a binary classifier. So practically what we do is we predict whether the student is able to answer correctly an upcoming question. Now, to operationalize the zone of proximal development, I propose the concept of the gray area. And the gray area is the area in which the student model's predictive accuracy is questionable. So the idea here is, if the student model cannot predict with acceptable accuracy whether a student is able to answer a question correctly or not, it might be an indication that then the student is in their zone of proximal development. And the research hypothesis here is that this area, the gray area, expands around the classification threshold of the binary classifier. And consequently, the area above the gray area signifies the cognitive state in which the student can carry out a learning task without any help. And the area under the gray area signifies the cognitive state in which a student is unable to carry out a task, a learning task, even if they receive help. So you see here we have a complete transfer of the zone of proximal development paradigm. So to go back in Remark's dialogue, right? For each question of the directed line of reasoning, it formulates a separate step. And this means that for every question, we can calculate with our model the probability of the student answering this question correctly or not, and therefore assessing whether the student is in their ZPD, zone of proximal development, above or below that. We have validated the gray area approach through both offline and online studies. And that means that on the one hand, we have collected data over 3 years from approximately 300 students, and we post-validated our hypothesis. And we also use this data to train the student models. And then we use the trained models in a real-time experimental study with 73 students from schools around the area Pittsburgh, where the student model was used to adapt the dialogue based on student responses. And that doesn't move. It moved too fast. Okay. So the results of our pilot studies revealed that on the one hand, it seemed that we are correct about the accuracy of the student model and how it increases as we move away from the classification threshold. So this suggests that our research hypothesis about the gray area being this area around the classification threshold actually holds true. And what we also saw was that students who practice using the student model, they learn significantly faster than the students who are not guided by the model. So that was about 30% faster. And this finding was confirmed both for students of high and low knowledge background, right? So both students who had significant knowledge and not. So we found out that they don't learn more, but they learn faster. Now, why is this important? Well, we kind of expected that we wouldn't discover learning gains between the two conditions since all students go through the same material, right? So our tutor is built in such a way so that all students go through the same material. But the difference between the conditions was that the more proficient ones, the one who had more knowledge or they were, they were more proficient, they skipped some steps, right? So it was expected or even desirable that the students should achieve the same learning objective, but they would do that more efficiently, which is what we argue here that is an important outcome. So this finding indicates that the tutor focuses on the material that students need help with and doesn't spend time on material that students have already mastered. So this leaves time for more challenging tasks and perhaps even sustains student interest. So currently I expand this work into two directions. And the first one aims to provide design guidelines for composing contingent feedback in terms of instruction, domain, and temporal aspects of learning. As part of this, I'm also exploring how the gray area can be adapted to support collaborative learning activities and to model interaction between peers from a cognitive and social perspective. And the second direction aims to implement the gray area approach to support environments other than intelligent tutoring systems that we are actually using more in Europe, right? So specific purpose environments, Jupyter notebooks, learning management systems like Moodle or even MOOC platforms. And with this message, I would like to conclude my talk and invite questions and comments. I will also present briefly two projects I'm currently working on the side. The one is a collaboration with the Council of Europe on human rights, democracy, and rule of law for AI in education. And what we're doing there is we're conducting a literature, we have conducted a literature review that will be published soon. We have a survey going on and some talks that we have been planning with policymakers and stakeholders from ministries of education, higher education institutes, and also primary and secondary school stakeholders on the benefits and the risks and the potential pitfalls of introducing AI in education on a scale. And the second is an Erasmus Plus project that we just kicked off, and it's called DigiReady Plus, and it aims to propose and implement a framework with some technical support for assessing digital readiness in higher education institutions. And to do that, we aim to design data-driven indicators and combine them with self-assessment tools like surveys and so on. These are my contact details that you see on your screen, and I would be really happy to hear from you. And with that, I will stop sharing my screen. Thank you.
Perfect. Thank you so much, Irene. Very fascinating as well. And I see some people in the chat are very excited to see the impact of Vygotsky and Bloom on student modeling and the design of data-driven systems. Before going to our next speaker, Vanessa, are there any questions for all our speakers so far for Henrik, for Irene, for Georgios maybe? Any comments?
I have a question for Irene. Thank you so much for your presentation. I have so many questions actually, but one of the questions that arises is basically, have you looked at teacher modeling beyond student modeling, and what does that sound like an exciting area to work with?
Yeah, absolutely. So we have not done that consistently. We have tried to do that implicitly when we were designing the tutorial dialogues, and then when we were designing the support that our student model gives. So we have carried out some basic work trying to map teachers' reactions and then model them. I think it's super interesting and definitely a direction to go. Okay, but just let me put it like that. I'm kind of afraid of the backlash that this might create, that we want to substitute teachers. And this is definitely something that we don't support, right? So teachers the human teachers should be responsible still for the classroom. But I think we have to learn a lot by how teachers carry out their lessons, right? So yeah, thank you for this question.
Perfect. Any other questions, comments? Even from the participants too? Actually, I was wondering, we talked about the potential of AI for supporting learning. We talked about ways to support AI education. I was wondering if you have identified, if you have seen any challenges when using AI systems to support learning or developing material for AI education. For example, in the LearnML project, one of the things that we saw is, especially when doing the teacher training courses or designing the educational material, is that, well, we wanted to follow a multidisciplinary approach, so as to show the impact of AI in different subject matters, in different fields. But in order to do that, in order to design the teacher training courses and the material, we had to consider the different fields of the teachers and the different computer skills of the teachers. And we also had to consider practical stuff. For example, how can the teachers in school cooperate with each other, how the computer science teacher can work together with the history teacher to do a multidisciplinary course on AI. And it's something that we had to cope with and see how to address this, because we had a lot of interest from teachers from other disciplines, like history, geography, literature, and of course, computer science teachers. So I was wondering if you identified any challenges in order to be able to implement AI effectively for learning.
So I assume this goes for me, right, Tito?
For everybody, okay. Actually, for all the speakers.
Since I am muted my microphone, I will just like to give my 2 cents. So we saw several things. One thing we saw was that teachers are overworked and they don't have time for more and new and, like more responsibilities, right? So one thing that we also noticed was that they really want to, but their resources are very limited. So what you mentioned, bringing teachers together actually worked well for us. So bringing the computer science, the informatics teacher with history teacher, and then, they exchanged ideas about their experiences and how they could make it work. That would mean, on the one hand, that they would kind of reduce the workload in the sense that, 2 people contribute for one, let's say, project and so on, and then they also share expertise. The other challenge that we faced, and we still face to some extent, is that we want to design one thing and the teachers don't really need it, right? Or they have different ideas about what they need. So for example, we went with this project that we were working on to Estonian teachers, and we were talking about, these adaptive learning environments and how, they can have these fancy instruction materials and so on. And they said, but these are things that we want to do ourselves. I mean, this is our job and we enjoy, to build our materials and to teach our students. So we don't really need the system to teach our students. What we need is help with administrative tasks, help with grading, help with reports, right? And this is, this is kind of miscommunication between different stakeholders. So I would say bringing, teachers in the discussion, what do you want to have in order to make your practice better and easier is always kind of my first rule and at this point.
Yeah, totally agree. I don't know, Henrik, if you want to talk about maybe the challenges, any challenge, any problems you had to cope with when designing the material and the chatbot.
I think it's not an easy task to design modules like the ones that we all design, I guess. So you all know some of the challenges. I mean, the art of selecting the right data and the right material, that is probably one of the most important challenges that we all need to face, because otherwise bias will be built into or integrated into the modules that we do. So I think AI ethics is definitely an aspect that we all need to sort of take into account.
Mm-hmm. Perfect, thank you. I see a comment about computational thinking. Desiree?
Yes, basically what I wanted to say is that I am very much, our situation, our experience in Malta is very much aligned to what Irene has just mentioned, that teachers were very much keen to embrace, so to say, AI into the repertoire of lessons. However, we have to make sure that they are in some way, AI is in some way embedded, not as an added, so to say, extra. But once they experience AI and the way it facilitates the teaching and learning of certain concepts within the curricula that they should be teaching, there was a lot of interest in our experience. So basically, I was very pleased to listen to what you were saying, Irene, that teachers are very keen. However, we have to facilitate the process. Even the way they interact with each other in such a way to learn from each other and to support each other. That was also very, very evident in our limited, so to say, experiences in Malta, but it's very much pronounced, as you were saying in your study. Thank you for that presentation. It was very interesting. Thank you.
Thank you, Desiree, for your comment. Any other questions or comments? If not, maybe we can go to our next speaker, Vanessa Camilleri from the University of Malta, as Georgios mentioned earlier. She's an AI expert, and actually she has written a book, a practical guide for teachers and students with lesson plans and worksheets on AI and machine learning education. And I will be also posting the link in the chat channel. So Vanessa, thank you very much.
Thank you. Thank you very much. And thank you to the speakers. Very interesting presentations. And thank you, Irene and Henrik. I think I might repeat a few things here because I totally agree with with what you were saying. So my presentation, I'll share my screen now. So is it? Yep. Here it is. So you should be seeing my screen. So my presentation today, so first of all, my name is Vanessa, as Iro kindly introduced me. I teach at the Department of AI, University of Malta, and I am also part of this really nice project, which is Learn to Machine Learn. So my presentation today is a little bit different because what I'd like to think a little bit or provoke some thought into in this very short few minutes that we have is about AI. So what really is AI? And we are living in the AI era, but do we, as people, and do our students and do their parents and do other educators really know what it means to live in the AI era? Some people might say that when you speak to people, and you know this, they might tell you that it means that robots are going to take over the world. There will be this kind of super intelligence that would threaten to wipe out humanity. They might also say that, the AI era means that at one point humans will step back and let the AI and machines do all the work for us. And no, not really. Irene, you mentioned the backlash with teachers and educators, that they might think, AI might take over their jobs. And in fact, it's not that. The question that, as you said, in fact, this generalized form of AI is not what we do, is not what is being done currently. At the moment, the importance of AI research, especially the research, focuses on this question. So how can AI and humans interact successfully together to solve a problem? So this is what it means for us. This is what we're after, to try and solve this problem. But let me show you a snippet of this video. It's just 3 minutes to introduce you to this age of AI. Okay, there are a series of videos and resources which expand on this concept further, which if you want and you're interested, I can give you the link to. But let's just hear a little bit about it. I hope I'm sharing the sound of it. Just a minute, please. I'll have to stop the share for a moment. Make sure that the sound is on. There you go. Okay, perfect. And here we go.
Welcome to YouTube Original Stages, once home to Howard Hughes' Spruce Goose assembly hanger and home to much of the first Iron Man, filmed 12 years ago. Many happy memories here. And speaking of taking a look back, technology. It's advancing faster and taking less time to be widely adopted than ever before. Like, as in it took roughly 10,000 years to go from writing to printing press, but only about 500 more to get to email. Now it seems we're at the dawn of a new age, the age of AI, artificial intelligence. Please define.
AI is a branch of computer science dealing with the simulation of intelligent behavior in computers.
Yeah, okay, there you have it. What does it mean? I don't know. Tons of folks are working on it, right? Most people don't know that much about it, and of course, there's no shortage of data or opinions. Anyway, I've heard it said that the best way to learn about a subject is to teach it. But to level with you, I have a wildly incomplete education. Not in my day job, where I've been AI adjacent for over a decade. Anyway, I figured now would be as good a time as any to catch up on the state of things regarding this emerging phenomenon. My sense of it is kind of feels like Pandora's box, maybe-ish. Much of my understanding on this topic has come from sci-fi stories, which usually depict us heading towards Shangri-La or dystopia. Like most things, I suspect the truth is probably somewhere in the middle. Now, along the way, we'll demystify some common misconceptions about things we thought we understood, but probably don't. Terms such as machine learning, algorithms, computer vision, and big data, they will be conveniently unpacked to help us feel like we know what we're doing. Kinda. By the way, Pandora's box. What in the box? It was a clay jar. How about that? demystified.
AI is teaching the machine, and the machine becoming smart.
Each time we create a more powerful technology, we create a bigger lever for changing the world.
Autonomous driving started.
It's an extraordinary time, one of unprecedented change and possibility. To help us understand what's happening, this series will look at innovators pushing the boundaries of AI and how their groundbreaking work is profoundly impacting our lives and the world around us. In this episode, we'll meet two different visionaries exploring identity, creativity, and collaboration between humans and machines.
Intelligence used to be the province of only humans, but it no longer is. We don't program the machines, they learn by themselves.
Okay, so that was a brief snippet of it. So basically AI is that branch of computer science that deals with creating systems that create machines that are able to function intelligently and independently within our diverse environment, from healthcare to self-driving cars, from games to everyday tasks. And even creativity. I mean, at the moment, I've got students working on projects trying to identify how AI can somehow become more creative, to create music, to create art. So what does our project mean for educators, for you? Why do we support and why do we help educators to join us in our vision of passing on concepts of AI and machine learning to our younger generation? Well, first of all, AI exposes children to a problem-solving way of thinking. It exposes children to coding skills from an early age, and it supports data fluency. And as you know, we are surrounded by all this data coming in from our digital medium, from the digital world we inhabit. And in effect, it can also open up critical discussion about humanity, as Henrik said. So as we know, our younger generations have grown up with computers. They don't know the world without it. And so we have, launched all over the world. So many countries have launched programs of giving children devices so that they are not left behind. No child is left behind. But we have given them devices and stopped there. What we need to do next is help them acquire the right skills to make the best use of what they have. Now, data, we can compare data to the electricity of this century. If we help our young people to understand what AI has the power to do with these huge data sets that we are surrounded with, then we might have in our midst, we might be teaching as educators a young person who will eventually develop a solution to a problem that can really change the world. Help a person become a visionary, like these people in these videos. So how do we teach AI? Now, our project, and this is where I repeat myself with Iro and with all the other speakers before me, our project emphasizes that AI should not be a separate subject. The importance of this project is to offer resources which can help educators, yourselves, integrate concepts of AI in multiple disciplines. That's the strength of it. If it is taught by itself, then it becomes more of the same, of the traditional way of approaching a subject from the book. Whereas AI, what we want to see with AI, what we want to see with this project is this idea of approaching AI from a problem-solving perspective, from the fact that, look, there is a problem within this field, within this subject, which AI can help solve. How? What can AI do to help solve that problem? So we would like educators to teach about the way AI functions, for example, by sensing information about the environment, how it learns through emulating the way humans learn, for example, using specific brain processes and functions. And we also think that it's very important, as Henrik mentioned again, to understand how AI can impact society in positive and negative ways. And therefore we teach about the ethics, the philosophy of having AI as part of our society, as part of the way we function in everyday processes. Again, there are various aspects of AI and machine learning. Here we see a few of them. We've got neural networks, data mining, algorithms, problem solving. They are concepts, but these concepts have to be integrated in all these beautiful subjects that you teach, because in reality, the whole world and how we live in is being impacted. So if I spoke about music, for example, there are really wonderful projects of AI creating music, but what does it mean for the AI to be creative? What are the implications? What is the ethics behind it, and how creative can that AI get? So again, there are loads of ways that we can explore the subject of AI together with different subjects. This is what I had to say. Thank you for your attention. Please feel free to ask me any questions. Thank you. I'll stop there.
Thank you very much, Vanessa. Thank you.
Thank you.
Any questions, comments? Hopefully we'll have some time in the end as well to have a longer discussion. So maybe we can go to our next speakers. Desiree Bugeja and Josmar Borg from Malta, from the Centre Pembroke. They will be presenting, they are also partners at the LearnML project, and they will be presenting the evaluation of the pilot courses, and also a case study from a teacher in Malta.
Yes.
Yes.
Josmar,
yes.
I'm going to share the presentation.
Basically, we'll be jointly conducting the presentation. But first, let me introduce ourselves. First of all, I am Desiree and Josmar. We're colleagues within the Science Centre. We form part of the Directorate for Learning and Assessment Projects, assessment programs within the Ministry for Education and Sport in Malta. And basically, we have embarked in this project related to machine learning because it's very much aligned to our vision within STEM education, the opportunity to have innovative practices to strengthen, to facilitate both the teaching and the learning. We have basically been active throughout the project, however, particularly in this part of the evaluation tool. One of the very important aspects of this tool is that this particular evaluation tool that has been designed for this project actually reflects an authentic classroom setup, in the sense that this is not a simulation. The teachers have been actually fully engaged, fully embracing, they fully embraced these tools, these AI tools. And it's not just the teacher who is, so to say, very much active, very much engaged in this process within this part of the project, but also the students are actively involved. And this brings me to the second point, that this particular evaluation tool offers the possibility of cross-validation of data, in the sense that the tool in itself takes into perspective both the students' experiences, challenges, learning styles, as well as the educator's full experience, the challenges the educator faces, the way it facilitated, the areas where there needs to be training, where there needs to be improvement to facilitate the inclusion of AI in everyday teaching. From the presentation at a later stage, we will actually have a mini resume of a teacher's experience within a primary, so to say, setup within primary science. And before moving on to what the actual tool will gauge, I'd just like to cruise you through the process of how we reached this phase of the evaluation, so to say, tool. First of all, the evaluation process was an initial part, an integral part of the project design. So the evaluation of the toolbox and of the game-based, so to say, learning was stated as an integral part of the project, from the planning phase, from the application phase. And it was very much based on a holistic approach, as I said before. So basically, after the evaluation plan, we identified which source would be used for an evaluation, for the evaluation in itself, to facilitate feedback from the users without making it too, so to say, hefty, too cumbersome for teachers. As I link again to what Irene said, teachers are extremely busy in classes. And now, notwithstanding that, okay, they are online, the teachers had to deal with plenty of new situations. And this created some sort of anxiety and tension for teachers. And it created a situation where they had to become familiar with other digital tools. So the tool is designed in such a way to facilitate participation and feedback. What's interesting is that the actual design of the tool, the actual questions that have been put forward show a collection of feedback contributions from all partners, from all stakeholders. So there was agreement about what we shall be evaluating, what feedback we are seeking, such that we can use the evaluation from this project to take AI forward within an educational context. Once the finalization of the evaluation tool was completed, there was the translation phase, which is obviously very, very important for the Norwegian teachers and the teachers from Greece. And now we are in a phase of data collection, data compilation. So basically, the teachers, the educators, and the students who are who are experiencing in some way AI during their lessons through the guidebook or through the toolbox, following their experience, they compile the feedback survey. Once this data, so to say, is inputted, once this phase of the project is over, the data will be analyzed collectively as a project. And obviously, one very important aspect of it will be the reporting, the conclusions, the action plan for the next steps. So basically, notwithstanding that the project will come, so to say, to an end, one very important aspect is that through the evaluation, through the authentic experience of teachers and students within this project, there will be an action plan to facilitate the introduction and the integration of AI within our classrooms. I leave it up to you, Josmar, for the next part of the presentation. Thank you.
Hi, everyone. Well, to supplement with what Desiree has been explaining, the evaluation tool is developed together to gather both quantitative and qualitative data. Obviously, the intention is to eventually we can enhance and improve the activities included in the LearnML guidebook, which has been developed by the LearnML organizers, of course, and which will eventually be available to all educators as an aid to support the delivery of AI activities vis-a-vis educational context and the students. But before, I'd like to also mention that at this age and time, it is important to know that education in general must make all the effort kind of to deliver, to pass on knowledge and awareness to our students as part of being digital literate. Okay, so besides the LearnML projects and the local contents, we already started implementing several changes in the technology-related subjects, okay, the ICT and, for example, the computing, where AI is being introduced both as an awareness and knowledge, and also from a more scientific point of view. We're introducing, for example, Python programming, programming of dedicated systems, etc., to kind of put forward the route for more students to get into courses, degrees, and masters in AI. So the data gathered from the evaluation tool is basically, first and foremost, we are gauging the educator's preference, whether they prefer transferring AI knowledge within curricular or extracurricular content. This is very important. For example, from the data collected so far, it's clear that students kind of prefer doing AI activities irrespective of their subjects. For example, if there's a mathematics teacher, the preference is usually to do an activity vis-a-vis AI related to mathematics. If we have a science teacher, they prefer to obviously deliver an AI activity within the context of science. So I think we should also try to support teachers or make our effort to also engage teachers in doing AI activities in extracurricular content. Okay. Then we are also gauging the learning objectives related to AI that the educators are choosing. They prefer to transfer knowledge about supervised learning or reinforcement learning, or perhaps AI ethics. That can also show us the kind of feed in AI, the most feed in AI preferred by educators to transfer to students. Also the resources they are using, what resources they prefer to use with the students. If it's a game, if it's an activity from the LearnML guidebook that includes digital tools such as online apps, or perhaps activities which does not involve digital tools, and the effectiveness of such tools. So we're asking about the effectiveness of the tools already prepared for them, and asking for suggested modifications. Okay. Also, we are targeting to get the positive aspects. So while the teachers are doing these activities, what positive aspects emerged from these activities, and what challenging factors exist in implementing an activity related to AI. For example, teachers might say that one of the challenges is that we don't have enough technological resources, or perhaps to use online apps in the classrooms, we need more powerful internet. So these are all challenging factors that we need actually to target as well. We are gauging also the students' experience. So besides the educators' perceptions, the students' experience is also important, because while the educator might perceive the activity as a success, okay, the students might see it was like it was difficult, or it was fun, or it was boring. So this can help us to compare the data gathered from educators and the data gathered from students. All in all, so far we're still waiting for more educators to provide feedback. But all in all, so far it looks like it is a positive. It is a positive pilot course, kind of. Teachers are being encouraged to deliver such activities in a moment where teachers are obviously passing from lots of changes in the local educational sphere, so they've got too much work to do. But still, some teachers have engaged and are interested in being engaged in this activity. Not to take too much time, now I'll be showing a video clip that includes the experience of one of our teachers, a science teachers, during the activity, her experience, her obviously opinions on doing an activity. If I'm not mistaken, it was a science lesson. So let me change.
I have implemented this pilot project in one of my Year 5 classes through the game AI for Oceans. I've chosen this game since it is in line with our primary science curriculum, and I have integrated this game with the topic, in which we discuss how humans impact the environment around them. Through this game, students could see that with AI, we can also clean the oceans. And first, we started discussing what AI is, and the students were very knowledgeable about this. And they could give examples examples of how they use AI in their everyday life. Then we continued discussing what machine learning is, and they were very eager to get to know more about this. Eventually, they played the game in which they gave instructions to the machine so that it could recognize fish from other things that can be found in the ocean, including rubbish. They were very engaged during this game, and they were very eager to complete it as they could get a certificate. Something which I found very positive, since there were foreign students in the class, they could choose to play the game using their mother tongue. So they were reading information, for example, in French. Finally, the students completed the feedback form, and so this was done as an English task. All in all, it was quite a positive experience, and I encourage other educators to use these resources in their classes and integrate them with the curriculum whenever possible.
Okay. Before concluding, something which I forgot to mention is that some of the feedback we had is that teachers had the impression that that AI is new to students. But it amazes us that some of the students are already knowledgeable about AI, are already aware that AI exists. So this is an encouragement also for other educators to perhaps also try these kind of activities. I'd like to conclude here. I don't know if Desiree has to add something. Hope it was interesting, but what is more interesting now is that when we gather all the data and evaluate it, get our conclusions and interpretations, we keep on enhancing on the tools already provided. So eventually we have a good package available for our educators.
Yes, thank you, Josmar. Basically, I think this brief experience shows us a holistic type of nature of how AI facilitated other facets of learning, not just for the STEM curriculum per se or for the specific use of AI, but the way that the students were motivated, the way they were engaged, the way they used language. So there's a lot of it. Perhaps as a thought, as a final product, one of the final products from this project could be, so to say, collation of mini experiences, like Beverly's, and such that in a brief manner they could be an inspiration to other educators who would need some encouragement to embark on using AI in their classes. Thank you.
Thank you, Desiree and Josmar. Any questions or comments? We have actually compiled a guidebook for the teachers. There are currently teachers like the teacher from Malta we saw that are implementing AI education related activities in their classrooms, and we are collecting data to evaluate how it went. We have we have compiled a guidebook with educational material, lesson plans, resources that teachers can use, and you can find the guidebook on our website, on the LearnML website. I posted the link a bit earlier in the chat box, so you can download and use it. Following up on this presentation by the teacher in Malta, we have two more teachers actually from Greece who will be presenting their activities. First, we have Elena Georgiou, who specializes in philosophy. She's a PhD candidate in modern philosophy at the National Kapodistrian University of Athens, and also a teacher at Palladio School, which is also a partner in the LearnML project, and she will be presenting her activity with her students and how she implemented it. And then we have Theodora Giapaggi, who specializes in creative writing in education. Her master's degree was on creative writing. She's also a teacher, and she will be presenting an activity involving artificial intelligence tools that can be integrated in digital storytelling, and explore how neural networks can transform creative projects in the classroom. So let's start with Elena and then with Theodora. Thank you both for being here and for sharing your experience with AI education.
Thank you for your invitation. Thank you for the invitation, dear Iro. Hello from Athens. My name is Elena Georgiou. As you already mentioned, I'm a school teacher and I have been participating in the LearnML program for 2 years now. I teach modern and ancient Greek literature and philosophy at the school, and that's why I had the chance to be a part of this program and have educational scenarios based on the games that we have seen the past few years. At the stage that we're in, after the development of educational scenarios, the next step was for the students to get to know how supervised learning, reinforced learning works. And this is our purpose during the lessons. In the beginning, the students has the opportunity to play the games and think about the impact of their decisions made when designing or playing a game. They started with artboard, where the goal was to learn the rewards and penalties through the commands that will be given to the agent. I informed them about the purpose of the game, which was to help the agent to collect as many statues as possible, and before leaving, avoiding the dangers. By changing the settings, the duration, or the exploration, they can observe the results. They found that every time the indicators of reward and punishment change, the final result also changes. Then they had the opportunity to choose a second game, Minecraft, out of code, and see the application of machine learning and the outcomes in a society like that of the farmers and fishermen. The purpose of the game was to help the agent bring the two teams together and work together to make progress in the community. Through the game, students have the chance to see what happens when we do not give data. So the machine must work with reward or punishment. We talk about the benefits of cooperation when it comes to a common goal and how they perceive concepts such as foresight, cooperation, justice, all those concepts that are taught in modern Greek or in philosophy. And at the end, the students were asked if they could apply supervised learning into other subjects of the curriculum, such as literature. In poetry, they can learn the machine to understand from the language, the style, or even the symbolism to which poet the poem belongs. This procedure was quite interesting, and the students were thrilled by the way the machine works. In fact, they knew already Minecraft. It was familiar to them. Students at first found it difficult to understand reinforcement learning or supervised learning, but when they saw how the game worked, they were able to process more easily. At that time, I will present you my educational scenario, and I will be sharing my screen. Just give me a minute. So Is that okay? Is that okay? You can see my screen?
Yes, yes, we can.
Yes, we can.
Okay. The educational scenario contains two games, Artbot and Minecraft. The subject was about ethical issues in modern Greek and philosophy. Learning objectives, the students understand the process of reinforcement learning, learn how a machine is based on artificial intelligence. They are introduced in the concept of reward and penalties, duration, exploration, rhythm, percentage of learning, understand the impact of decision made during designing or programming a game based on artificial intelligence. They understand that whenever reward and penalties indicators change, the result changes too. Students are led to questions for the impact of machine behavior on ethical and philosophical issues. They are concerned about provocation, cooperation, responsibility, bias, justice, things that appear in common at the lesson of modern Greek and philosophy. Learn the benefits of cooperation to achieve a common purpose. They wonder whether artificial intelligence works for the benefit of humanity and human well-being individually and socially. This type of educational scenario appears in the classroom, and the teaching approach has to do with the goal that it's to learn the rewards and penalties through the commands that they will give to an agent playing the artboard game. Then they can play Minecraft to understand the results of their actions and the benefits of cooperations. We expect the time to be 40 minutes for artboard, or if they want to play both of games, 2 school hours, about 1 hour and a half. The procedure now. The teacher makes an introduction to artificial intelligence and reinforcement learning, informs students about the operation of reinforcement learning and its difference from supervised learning, presents the artboard game in the classroom, explains that it works with AI, explains that the purpose of the game is the students to help agent collect as many statues as it can by avoiding traps before exiting the room. The game has 10 stages. To move to the next stage, they should have picked up at least 1 statue. As for the students, they choose the second game for the original directory, the game of reinforcement learning. They can either play the game individually or in 2 groups and discuss the results of their choices in the end. Search for information, clarification of the indicators of settings and functions. Change the settings of duration, exploration, experience, and learning rate at a time and observe the results. Use the indicators to define positive, negative, or no reward for fighting items in the room. Supplementary materials. Teachers should have worksheets and the students can play Minecraft to see the extension of reinforcement learning and result in a society such as farmers and fishermen. Age of students between 12 and 17. No experience is required for artboard. Knowledge of code is required for Minecraft. The replying key is given to the students in order to proceed during the game. Assessment of learning objectives through the worksheets of students who evaluate the game through teachers' worksheets and I will show you in the end how about these worksheets. We give them to students or to the teachers at the end of the procedure. Finally, the assessments of activities with the goals and scenario want the students to understand the role of the machine, what happens when they do not give data and the machine must work with reward or punishment, the role of the machine in resolving everyday issues, and the importance of a foresight in resolving problems. To evaluate the strategies that they have used to link and transfer moral dilemmas to school courses through games, to recognize interaction relation prejudice, to answer specific questions related to the teaching object at the worksheet that we provide to the students, to collect the answer and discuss the results. And in teacher, we give a supplementary material that includes a useful terminology for artificial intelligence, link with games, Minecraft coding, solution guide, questionnaire. I will show you later working sheet for profession and working sheet for students. And this is a working sheet for professors, a general introduction of artificial intelligence, a discriminate concept of supervised and informed learning, installation, some instructions, and at the end, indicative question for questioning and conversation in the class. Working for students, installation instructions, indicative questions for questioning and conversational in the class, and a questionnaire.
Yes.
Okay, is everything okay, Iro?
Perfect. Thank you, Theodora. Yes.
Okay, I am glad to attend another LearnML event. And this time I'm happier to have the opportunity to share my educational scenario, which is a combination. It is a combination of artificial intelligence and specifically generative artificial intelligence and digital storytelling. Let's start with some basic information about this activity. This is an interdisciplinary lesson. It is suitable for students at least 9 years old. And I don't want to give a range with a maximum when it comes to playful and creative challenges, nor is the duration well defined. If you go for an extended storytelling, it will take a long time. But if you want to create a kind of cards with scenes or something like a short clip, a short comic strip, you will need less time. My implementation lasted about 3 hours. During this activity, students are expected to enhance their creativity. And what is more, they are going to redefine it, since AI enriches the narrator's digital toolbox and provides also new meanings in human-machine co-creation. This will be clarified soon. Regarding AI literacy, students will become familiar with text-to-speech technology and deepfakes. And most importantly, they will need to consider the implications of machine learning advances. There's also the opportunity to practice English language skills. In any case, we know that many AI models are trained with data found in English. So here is an overview of the steps of my activity. Digital storytelling, by definition, is likely to lead to a multimodal text containing words, images, sounds, music, and I have linked each of these parts to a tool powered by artificial intelligence. So the steps of building a short digital story, or just a scene anyway, are all articulated in conjunction with these tools. After creating and collecting the materials, there is a phase of bringing all the components together using some kind of software. Not necessarily AI-related software. Now we'll dive into every part of this branching diagram. In the beginning was the word, and the first tool uses deepfake tech, specifically text-to-speech, to make popular characters say stuff with their voice. And it is you who puts words in their mouth. The voices are categorized. I found Elon Musk in real people filter. So encourage kids to browse the drop-down menu and pick a voice. Cartoon, comic, and superheroes are ideal categories for them. My students chose Batman, Spider-Man, Dora the Explorer, and Sonic the Hedgehog. I had known this character. All you have to do is type a sentence in the corresponding field, click on the speak button, wait a few seconds, and then listen. And now please listen to this.
I want to be invited in the next Learn Machine Learn event. In the next Learn Machine Learn and Learn event to be in.
Okay. To me, the first seconds are quite impressive. The voice is almost indistinguishable from the real Elon. But soon some errors happen and make you wonder if Elon has put himself in some pilots of its Neuralink project and something went wrong with the brain implant. And this example reflects the actual experience. Sometimes the result is satisfactory. Sometimes you will need to edit the audio file and cut it, or just try another phrase. I deliberately left it as it was. And I would also like to show you this page and focus on this part. Your brain was already capable of imagining things spoken in other people's voices. This is a demonstration of how far computers have caught up. And I find this interesting because it has to do with something previously mentioned in the goal setting slide, the aspect of redefining creativity. A futuristic claim follows, which is also a topic of discussion. One day computers will be able to bring all the reads and do it imagery, etc., etc. Therefore, give your students time to explore the site, select a character, come up with the words, try a phrase, retry if needed. Another idea here is to write a dialogue between AI-generated voices and real voices, even student voices. And so kids will have a more realistic imaginary conversation with their favorite characters. My students had such an experience as they also practiced speaking skills. You can see this in the following page.
You have a nice car, Batman.
Thank you very much.
This is the Batman, the AI-generated voice. Next, the visuals. What about trying a new style of coloring in our pictures? Go to Tiger Paint and upload the sketch image. On the left side, you see a sketch made by one of my students who happens to be a big fan of Sonic the Hedgehog. So he drew an outline. We used the scanner app, time scanner in my mobile phone, and we uploaded it. In the right, the sketch is colorized with one of the suggested themes you can see above. But you can intervene to make a more customizable result. Choose colors to give a hint. A mere purple line in the background gives a direction to the model. It's beyond the solid color. We have an interesting sense of shades and gradient coloring. And proudly present you the first scene of my students' experiment.
Hey, Amy, how are you?
And as you can have a revision here in the diagram of the steps followed. One observation, too detailed sketches or blurred outlines will not work, so advise kids to draw clear boundaries. As I reflect, we should also have avoided the bubbles. You have probably noticed that there is a distortion around bubbles, so better to put them later in some other digital way. Music. If you fancy soundtrack, some simple musical phrases in your artwork, Piano Zini is here to help. Thanks to a model trained on a set of musical performances, it has recognized some patterns, so that even if you play random keys, the outcome is a coherence. It's not like the ear-bleeding track you will take when you play random keys on a real piano. Record and save the composition to include it in the digital storytelling. And once each part is ready, it's time to assemble. This requires efficient file management. This is why it's important to name the files when you download and save them. The presentation can be done in Scratch, a video editor, PowerPoint, Google Slides, various tools can be used. I like Scratch because I like coding lessons. And one more reason is that Scratch includes a couple of artificial intelligence extensions. Here you can see how they are used in one of our projects. So Scratch provides another opportunity to study AI and sparks curiosity about how it works. To come to closure, reflection upon the completion of the activity is a truly insightful step, and my favorite one. Overall, this is a lesson plan aligned with the last option in this section of the Google form given to us for pilot courses. It may ignite thought-provoking discussions about the nature of creativity. How do students perceive this co-creation compared to more traditional ways of telling the story? We can ask them, what horizons does AI open for a creator? And second, deepfake implications is a hot topic. Young people are probably aware of the TikTok trend, and the teacher is also encouraged to show them some striking case studies of deepfakes, deepfake queen, for instance. Some questions to organize a debate are, we have used deepfakes for fun and for creative purposes, but can you think of any immoral uses? What precautions should be taken to address the dangers of AI in the wrong hands? Decider is a tool which allows space for brainstorming and argumentation. We can add our ideas, note the pros and cons, vote. And now you can see some screenshots in Greek, but this can be solved with a little help from Google Translate and Google Lens. And see, AI is everywhere. I hope you can get the gist of this activity, even if you cannot see the letters, all the words. I do dare to share a teaching idea which is more like a social experiment, the deepfake conspiracy theory. First, select an influential person, produce a shocking deepfake audio file to support conspiracy theory, disseminate and present as if it was true, check reactions, do people believe it, and reveal the concept. After a while, raise awareness of tackling misinformation. I strongly recommend audio files because they could be more persuasive than videos. But still, I experimented in the video feature FakeU has, just to show the potential of deepfake and get a glimpse of the future of fabricated content.
I will put all vaccinated in a Tesla. We will go to Mars.
The job has installed Windows Marshall 23, ready to launch.
Release the Metastates project.
On my references page, I'd like to point out that the LearnML guidebook Iro mentioned before has an extensive list with inspirational resources. Vowel Codes is a former name of FakeU. It has been rebranded. And a host of tools can be found in AI Basics for Schools MOOC. by European Schoolnet, and that is also transition to the next page. Here you can see that I'm also a scientist ambassador, so I strongly encourage you to submit your activity in the STEM Discovery campaign of this year, where teachers from all over the world celebrate STEM, and you are welcome to be a part of it. And I have also included a couple of resources of AI-themed resources found in a scientist repository in the next page, where all the links are gathered, all the links I mentioned before. So that's all for now. I will be happy to know if you try any of these tips in your classes. Please let me know. I don't know if I have the opportunity to share this presentation and the resources somewhere, maybe on the page of the project, or if you could forward it to the participants.
We could upload it on the website, if you don't mind, Theodora, maybe together with the educational material.
Yeah, and this entire presentation is recorded already, so it will be available on our YouTube channel. So thank you. It's awesome presentation. Yeah, we can do that. If you want to, we can upload it on our material.
I would just like my colleagues to have the links and try out themselves in the classes.
Yes, awesome.
Perfect. It would be great if you could copy paste the links in the end in the chat box, Theodora.
Yes, of course.
And also if you could post the link to the Scientix challenge, the STEM activity challenge, for people interested. If you can post the link.
I will do it right now.
For submitting the activity, that would be great.
Thank you very much.
Thank you again, Theodora and Elena. Very interesting activities, different approaches to teach AI through various subjects, through various tools. Thank you for being here. I don't know, any comments, questions from the audience? I have posted two links on the chat. It's two forms. Please fill in the forms. We need them both for the European Commission to submit them. So the one is the evaluation of the event today, and the other one is for your participation here. So please fill it in if you want to receive a certificate of attendance, or if you just want to be notified about future events or projects we're doing at the Institute of Digital Games. So please fill in those two forms. They will only take 5 minutes, both of them. So we are right on time, maybe 5 minutes late. So any questions or comments? Or if anyone from the audience wants to share their experience? If not, thank you all for being here.